Howdy. In this video, what I'd like to do is to prove to you the two angle addition identities for sine and cosine. The identity that sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. And the identity cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. My guess is that in trig class you probably memorized these as brute facts. And I'd like to show you why they're true. In fact, the star of our proof is going to be this diagram that you see in front of you. This diagram is actually called a wordless proof of the two identities. In other words, if you study this diagram and figure out why all the angles and sides are the way they are, you actually understand the proof. And so the first thing that I'm going to ask you to do is, in just a moment, to pause the video and see if you can figure out the proof from this diagram. I'll give you a hint. Start with a given of 1 as the hypotenuse of this right triangle right here. And take the angles alpha and beta as givens also. And from those three givens, you should be able to work out all of the other text that we have here in blue and red and green. So I'm going to ask you to pause the video at this time and see if you can work it out on paper for yourself. And when you're done, as much as you can get done, come back and we will see if our reasoning agrees with each other. Please don't skip this part of the exercise because trying to figure it out will help you understand what I'm saying in just a moment. Welcome back. Let's take a more detailed look at this diagram now and see why it proves the two identities in question. If we consider two right triangles whose angles are alpha and beta, then there are three ways that we could put those two triangles together so that we get the angle alpha plus beta. One way would be to match the right angles together like so, and that gives us the angle alpha plus beta. The second way would be to oppose the right angles across from each other. And the third way, which is the way that we've chosen here, is to make the right angles be sequential, so that the leg of triangle here becomes the hypotenuse of the triangle here. So let's take this third approach, and this gives us the angle alpha plus beta, and we're going to give the hypotenuse an arbitrary length of 1. We could rescale this whole figure to any size that we want. And now let's immediately use our right triangle representation that we talked about in the other video to mark up the sides of our two right triangles. If this hypotenuse is 1, then immediately this side right here is sine beta, and this side right here is cosine beta. And because this leg is the hypotenuse of the blue triangle, then we can represent the blue triangle as having legs of cosine beta times sine of alpha and cosine beta times cosine of alpha. So that's nifty, and it's encouraging because we're starting to see elements of the expressions found in our proof. So that suggests to us that we're on the right track. Now what we'd like to do is to take and do extend. First of all, we're going to extend the leg of this right triangle straight up so that we have a right angle here. And we're going to extend the, we're going to make a perpendicular to the bottom leg here from the vertex of the triangle. And so when we do that, we now have two perpendicular lines that are therefore parallel to each other. And through those lines, we're going to drop a perpendicular to each of those lines from the vertex here. So we have four right angles. Okay. Now, having put all of that scaffolding in place, let's see what we have. What we have are two new right triangles. We have this guy, and we have this guy. I'm going to do him in red also. Okay, so let's see what we can figure out. First, let's figure out this angle. Notice that this angle is going to be complementary to this angle because we have a right angle here, and so these two must add to 90 degrees. Their measures must add to 90 degrees. And we already know that this angle is complementary to alpha because it's those two are the acute angles in the right triangle. So that means that this angle must be alpha. And this right triangle has a hypotenuse of sine beta, so we can immediately use our representation to write the legs here as hypotenuse times cosine alpha and hypotenuse times sine alpha. Okay. What about this triangle over here? Well, again, this angle is complementary to alpha plus beta, and it is also complementary to that angle there, so this angle must be alpha plus beta. We can immediately represent, therefore, this triangle as 1 times sine of alpha plus beta, and this side right here as 1 times cosine of alpha plus beta. Well, the game is won because we have in our diagram the expressions that we're looking for, sine of alpha plus beta and cosine of alpha plus beta. So let's immediately use the fact that we have a nice big rectangle to write expressions for those sides. First of all, we can immediately say that sine of alpha plus beta on the left is equal to the right side, which is sine beta cosine alpha plus cosine beta sine alpha. And with just a little bit of commutative action, we get the identity that we were looking for, sine alpha cosine beta plus cosine alpha sine beta. And if we match the top sides together, then we have cosine of alpha plus beta plus sine beta sine alpha equals cosine beta cosine alpha, and some subtraction gives us what we were looking for here. Ta-da! Isn't that nice? I used to prove these identities using law of cosines and distance formula, and this is so much of a nicer way to do it. And it's nice because it's fairly easy to remember. What we're doing is taking the two right triangles and arranging them so that we get the angle alpha plus beta by stacking the right angles on top of one another, and then just filling in the rest of the diagram. Well, before we finish, I would like to use these identities to get a couple of nifty results. Obviously, we're begging for some angle subtraction identities, so let's immediately do that. Before I do any proof, I'd like for you to pause the video and see if you can use the angle addition identities to come up with a good result here. Welcome back. We're going to think of subtraction as adding the opposite. And so we can use or leverage our angle addition identity. And now we remember that cosine of negative beta is the same thing as cosine of beta because cosine is even. And sine of negative beta is the same as negative sine of beta because sine is odd. And lo and behold, we have an angle subtraction identity, which is usually written canonically in a way that parallels the angle addition identity. Same song, second verse. Again, we're going to think of subtraction as adding the opposite. And so using our identity for angle addition, using the correct identity for angle addition, which is cosine alpha, cosine negative beta, minus sine alpha, sine negative beta. And again, appealing to the even and odd properties of cosine and sine, we get this result right here. And there's our angle subtraction identity. So, it's pretty nice. One diagram effectively gives us four things. But wait, there's more. Because if I wanted double angle identities, and I frequently do want double angle identities, then I can generate those with the angle addition as well. If I want sine of 2 alpha, I can simply rewrite that as sine of alpha plus alpha. And using angle addition, I get sine alpha cosine alpha plus cosine alpha sine alpha. But these are exactly the same terms, so that I get 2 sine alpha cosine alpha. This is the famous double angle identity for sine. And likewise, if I use angle addition here, I get one of the famous double angle identities for cosine. I'm going to say more about these double angle identities in class tomorrow. Hope you've enjoyed the video. What do you need to know for this? Well, first of all, you should absolutely positively know your angle addition identities and know how to use them to generate the angle subtraction identities and the double angle identities. So you should definitely practice doing that, talking through that after you turn off the video. And then I would also encourage you to walk through the proof a couple of times of the angle addition identities. The proof is actually not so hard once you remember how to set up the diagram. Take care.